Hi everybody, I'm Louis and I'm happy to be here. So today we'll be talking about network asset modeling with ElasticSecurity, SIEM. We'll walk through a use case, and the goal of this use case is to detect and alert on access to critical asset. And the stack components that we'll be using will be the detection engine based on 7.11.1. It's running on an Elastic Cloud deployment. We're also using the Packetbit pure default Packetbit running on a remote CentOS box in this case. Finally, an ingest pipeline to add timestamp field to the incoming events. For the mapping, we'll be creating a network asset model list with mappings. Particularly, the timestamp is very important here. So basically, it's to comply with the Elastic Common schema, the ECS format. We need this for the rule to run properly. And the second field, server.ip, this is the field that we're going to use to match in the Packetbit event later. For the ingest pipeline, it's basically a simple pipeline to add a timestamp field, the add timestamp field for every incoming document. So this is to, again, align with the ECS format. So a sample document looks something like this. Probably this is an oversimplified one. In production, you probably be expecting more fields. So for the simplicity of this use case, so this is what it looks like. And the server IP, again, we will use server.ip to match the resource field in the Packetbit event. So in the detection rule setting, we are using an indicator match rule. And you can see the index pattern that we will be querying the rule queries against the Packetbit index. For the indicator index pattern, this is the network asset model list that the rule will match against. And indicator index query here, we specify timestamp now for within the 24 hours or within 1 day. So this is to cater for cases where you're expecting updates to your network asset model list and you want to use the latest event. So for that, we actually toggle the KQL syntax to Lucene. And for the indicator mapping, again, you can see here we're using resource field in the Packetbit index to match the server.ip field in the network asset model index. And in summary, the rule setting looks something like this. It's running, if you look at the schedule, it's running on every interval of 5 seconds with an additional loopback time of 1 minute. So the last but not least thing here will be the rule action. We'll be using the Webhook Action to initiate an API call to auto create a case when the rule triggers. So basically this completes the overall workflow. And something to take note is the post URL method, the syntax, and the settings that is required. So in summary, you can, the screenshot here will give you a rough idea of how to set it up. Finally, the rule action contains placeholder variables. So these are variables that you can use to create more context when the rule triggers and create a case. The details are actually using the context of the rule itself. So later on, you'll see how basically forms up. And then once we have the rule running, we will trigger the rule by doing a dig, basically a DNS query using the same IP. So if all goes well, the detection rule fires, and you can see over here, the field that we are showing is dns.question.name, and instead you might, in case you are asking where is the resource field, right? That's because resource field is not part of the ECS format, so it's basically not being able to be passed out here, and instead we are using a DNS question.name format, which is part of the ECS format. And finally, you can see the case being created in the cases tab. And you can see the rule name being part of the placeholder value. And also the details of the list, the message body that we put in, it translates to something like this now. And you can see we also created a critical tag field to symbolize that this rule is critical, and it allows you to prioritize a remediation workflow. So thank you.